2010 questions. The question type we have is type B. Question 1 says, which physics question paper type is given to you? So you go ahead and type in that. The type we have is B. Question 2. Two cars moving in the same direction have speed of 100 km per hour and 130 km per hour. What is the velocity of the faster car as measured by an observer in the slower car? The correct option to this is option D. 30 km per hour is the correct option. Question 3. The diagram above shows a velocity time graph. The statement that it is true about this motion is that the car A. Decelerate between point F and H. B. Accelerate between point F and G. C. Has a constant speed between point E and F. D. Has an acceleration between point F and G. The correct option is option D. Has an acceleration between point F and G. Now if we look at our graph, you see that point F to G, there is an acceleration. So this is the correct statement from this diagram. Question 4. A stone and a feather are dropped from the same height above the Earth's surface. Ignoring air resistance, which of the following is correct? A. The stone and feather will both reach the ground at the same time. B. The stone will reach the ground first. C. The feather will reach the ground first. D. The feather will be blown away by the wind, while stone will drop steadily. Now, let's take a very close look at the question. A stone and a feather are dropped from the same height. Say you climb a building and you drop a stone and a feather from the same point. They said we should ignore air resistance. So which of the following is correct? So if we are to ignore air resistance, the stone and the feather will both reach the ground at the same time. So A is the correct answer. Question 5. A car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? For us to get the acceleration of the car, we'll use the formula U equals to V minus U over T. Now we have all our answers here. Our V is equals to 45, our U is equals to 25, and our time is 10 seconds. So if we put all back into our formula V minus U over T, we'll have 45 minus 25 all over 10. And this will give us 2 meters per second. And from our option D is where we have 2 meters per second squared. 6. An object is weighed at different locations on the Earth. What will be the right observation? A. Both the mass and weight varies. B. The weight is constant while the mass varies. C. The mass is constant while the weight varies. D. Both the mass and the weight are constant. The right option here is option C. If an object is weighed at different locations, the mass is constant while the weight varies. The mass of that object doesn't change. It's the same mass anywhere you take it to. But the weight at that particular point in time when you are measuring it might vary. Question 7. The diagram above represents balls in an undulating surface. Which of the following options represent position of a stable equilibrium? A. II, V, and VIII. B. IV, and VII. C. III, VI, and IX. D. III, IV, and VIII. The correct option is C. III, VI, and IX. Question 8. A bulb of width 0.1 N hangs from a massless string of length 50 cm. A variable horizontal force which increases from 0 is parallel to pull the bulb until the string makes an angle of 60 degrees. With the vertical, the work done is A. 0.250 joules. B, 0.025 joules. C, 0.050 joules. D, 0.500 joules. If we take the formula W equals to Fs and we substitute our F and S there, we will arrive at the answer 0.05 joules, which is option B. Question 9. The surface of a conveyor belt are made rough so as to A. Prevent the load from slipping. B. Making them stronger. C. Enable them to carry more load. D. Protect them while carrying loads. The correct option is option A. The surface of a conveyor belt are made rough to prevent the load from slipping. Question 10. A machine of velocity ratio 6 requires an effort of 400 Newton to raise a load of 800 Newton through 1 meter. Find the efficiency of the machine. Now, for us to calculate the efficiency of a machine, MA, we say MA is equals to L over E, which is our L here is 800 and our E is 400. So when we divide through, we get 2. So our MA is 2. This implies that E equals to MA all over VR times 100 over 1 because we are calculating the efficiency. So our MA we've gotten as 2. Our VR from the question is 6. So we'll now say 2 divided by 6 times 100 over 1. When we cancel them out, we will get 33%. And in our option here, the closest option to this is option C, 33.3. Is the closest option, but what we got from our calculation is 33%. If a wire 30 cm long is extended to 30.5 cm by a force 300 Newton, find the strain energy of the wire. Here we have to calculate the strain energy of the wire. For us to do that, we say K is equals to F over E. Our force is 300 and our E is 0.05. So our K will be equals to 60,000. This implies that our E, which is the strain energy we have to find, is 1 over 2 times KE squared. This will be equals to 1 over 2 times 60,000 times 0.05 squared. This will give us 0.75 joules, and that will be option D. Question 12. In a hydraulic press, the pump piston exerts a pressure of 100 PA on the liquid. What force is exerted in the second piston of cross-sectional area 3 meter square? We'll use the formula F over A equals to F, capital F now, over capital A. This will be equals to 100, which will be equals to F over 3. Therefore, our F is 300 Newton. That is option D. Question 13. The accurate measurement of the relative density of a substance in its powdered form is done with a beam balance and A, an Eureka can, B, a burette, C, a pipette, D, a density bottle. The correct option here is option D. For us to measure the accurate relative density of a substance, we use a density bottle. Question 14. A hydrometer is an instrument used in measuring A, density of liquid, B, relative density of a liquid, C, relative humidity of liquid, D, vapor pressure of fluid. The correct option here is option A. We use a hydrometer to measure density of a liquid. Question 15. One special advantage of alcohol over mercury as a thermometric liquid is let me take that question again. One special advantage of alcohol over mercury as a thermometric liquid is its A. Low freezing point, B. Low boiling point, C. High specific heat capacity, D. Low density. The right option here is option D. The advantage of alcohol over mercury as a thermometric liquid is its low density. 16. Two metals P and Q of length L1 and L2 are heated through the same temperature difference. If the ratio of the linear expansivity of P to Q is 2 to 3, and the ratio of their length is 3 to 4, what is the ratio of increase in length of P to Q? Now, for us to find the ratio of the increase in length of P to Q, let's use the formula L2 minus L1 times P all over L2 minus L1 times Q. This implies that the change in L1 of this temperature and the change in L1 of the temperature equals to 2 times 3 times the change in the temperature all over 3 times 4 times the temperature. This will be equals to 1 over 2. And this will give us a ratio of 1:2. Question 17. The density of a certain oil on frying becomes 0.4 with a volume of 20 meter cube. What will be its initial volume when its initial density is 0.8, assuming no loss of oil due to spillage? The mass is equals to D times V. So we have 0.4 times 20, which will give us 8 kg. Therefore, mass over D will give us the volume, right? So we will now have 8 all over 0.8 will give us 3 meter cube. And that is our option A. Question 18. Heat is radiated by all hot objects in the form of A. Light energy, B. Solar energy, C. Infrared rays, D. X-rays. Heat is radiated by all hot objects in the form of infrared rays. Question 19. If a container is filled with ice to the brim, what happens to the level of water when the ice completely melts? A. The water in the glass outflows. B. The level of water drops. C. The level of water remains unchanged. D. The level of water goes up. The right option is option B. The level of water drops. 20. The small droplet of water that forms on the grass in the early hours of the morning is A. Dew, B. Mist, C. Fog, D. Hail. The correct option is A. Early in the morning on our grass in our neighborhood, you see dew on the grass. 21. A vapor is said to be saturated when A. Dynamic equilibrium exists such that more molecules return to the liquid than are leaving it. B. The vapor pressure is atmospheric. C. The temperature of the vapor varies. D. A dynamic equilibrium exists between liquid. The correct option here is option D. A dynamic equilibrium exists between liquid molecules and the vapor molecules. 22. The pressure of 1 mole of an ideal gas of volume 10 at a temperature of 27 degrees centigrade is A. 2.24 times 10 raised to the power 4, B. 2.24 times 10 raised to the power 5, C. 2.49 times 10 raised to the power 5, D. 2.49 times 10 raised to the power 4. We have to take molar gas as constant to be 8.3 joules per mole per Kelvin. If we take the formula P equals to nRT over V, and we have all the other values there, we can substitute this value into this equation, into this formula, and then we'll arrive at our answer. So 1 times 8.3 times 300 all over 10 raised to the power minus 2. This will give us 2.49 times 10, and this will give us option C. Question 23. Which of the following has no effect on radiation? Density has no effect on radiation. Temperature. C. Surface area. D. Nature of the surface. The correct option here is density. A. 24. The wavelength of a wave traveling with a velocity of 420 meters per second is 42 meters. What is its period? For us to calculate the period, we'll need to first of all find the frequency of this wavelength. So if we use the formula F equals to V over lambda, we'll get 420 over 42, which will give us 10. But the period, which is T, is equals to 1 over F. 1 over 10 is equals to 0.1 second. So B is our correct option. The sound of an electric bell dies down slowly when air is slowly pumped out from a bottle because A. Sound cannot pass through the bottle. B. Sound can pass through a vacuum. C. Sound needs a material medium. D. The wavelength of sound becomes greater in the bottle. The correct option is option D. The wavelength of sound becomes greater in the bottle. 26. During a thunderstorm, the sound is heard over a long time. This phenomenon is referred to as A. Refraction of sound. B. Reverberation. C. Superposition. D. Diffraction of sound. The correct option here is option B. Reverberation of sound. 27. The velocity of sound in air at 16 degrees centigrade is 340 meters per second. What will it be when the pressure is doubled and its temperature raised to 127 degrees centigrade? A. 4,000 meters per second. B. 160,000 meters per second. C. 8,000 meters per second. D. 400 meters per second. The correct option here is option D. 1 degree centigrade is equals to 0.6 meters per second. Therefore, 111 degrees centigrade is equals to 66.6 degrees centigrade. Therefore, speed, which is equals to 340 plus 66.6, will give us 406.6 meters per second. 28. In comparing the camera and the human eye, the film of the camera functions as the iris, B. Pupil, C. Cornea, D. Retina. The correct option here is D. Retina. The film of the camera functions like that of the retina. An object 4 cm high is placed 15 cm from a concave mirror of local length 5 cm. The size of the image is this. First of all, the question is not correct. It's supposed to be of focal length, not local length. So the size of the image is A. 3 cm, B. 5 cm, C. 4 cm, D. 2 cm. So the correct answer here is D. For us to get the focal length, we use the formula 1 over V equals to 1 over F minus 1 over U. This is a popular formula in our physics. So we are going to record this formula and use it here. The object is 4 cm high and is placed 15 cm from a concave mirror. So here we'll have 1 over 5 minus 1 over 15. This will give us 7.5. So our 1 over V is 7.5 centimeter. But for us to actually find the size of the image, we use the formula HI equals to HOXY all over U. This will give us 4 times 7.5 all over 15. And this will be equals to 2 centimeter. Question 29. An object 4 cm high is placed 15 cm from a concave mirror of focal length 5 cm. The size of the image is A. 3 cm, B. 5 cm, C. 4 cm, D. 2 cm. The correct option here is option D. 2 cm. Question 30. An object is embedded in a block of ice 10 cm below the plane surface. If the refractive index of the ice is 1.50, the apparent depth of the object below the surface is A. 6.77 cm, B. 7.63 cm, C. 7.50 cm, D. 2.50 cm. The correct option here is option A. 6.67 cm. For us to calculate the apparent depth of the object, we use the formula AD equals to R times D all over N. And our RD from the question we're given is 10. And our N is 1.5. So when we divide this through, we get 6.67 centimeter. Question 31. Which of the following is used for the correction of short-sightedness? A. Concave lens. B. Concave mirror. C. Convex mirror. D. Convex lens. The correct option is option A. We use a concave lens. We use a lens for correcting short-sightedness. We use lens, not mirror. So what we have here is concave lens. 32. Dispersions occur when white light passes through glass prism because of the A. Different speed of the color in the glass. B. High density of the glass. C. Defects in the glass. D. Different hidden colors in the glass. The correct option here is option A. Different speed of colors in the glass. 33. When a positively charged rod is brought near the cap of a positively charged electrode, the leaf's divergence will A. Converge. B. Remain constant. C. Diverge. D. Be induced. The correct option here is C. Diverge. Question 34. Three capacitors of capacitance 2, 4, and 8 are connected in parallel, and a potential difference of 6 volts is maintained across each capacitor. The total energy stored is A. 6.90 times 10 raised to power minus 6 joules. B. 6.90 times 10 raised to power minus 4 joules. C. 2.52 times 10 raised to power minus 4 joules. D. 2.52 times 10 raised to power minus 6 joules. The correct option will be our option C. So how do we get to option C? First of all, we need to calculate the capacitance of the three capacitors. So the capacitance of the three capacitors is C1 plus C2 plus C3. That is 2 plus 4 plus 8. And that will give us 14. So now that we have that, we can now say that our energy is equal to the capacitor times the volt, the potential difference, all over 2. This will give us 14 times 10 raised to power minus 6 times 6 square, all over 2. So our final answer will be 2.56 times 10 raised to power minus 4 joules, which is option C. 35. A cell of EMF 12 volt and an initial resistance of 4 ohms is connected to an external resistor of resistance 2 ohms. Find the current flow. A. 4 amp. B. 2 amp. C. 3 amp. D. 5 amp. The correct option here is option B. For us to get our amp, our current is equal to E all over R plus small r. This will be equals to 12 all over 2 plus 4. And this will give us 2 amp. 36. The diagram above shows a balance meter bridge. The value of X is A is 66.7 centimeter, B is 25.0 centimeter, C is 33.3 centimeter, D is 75.0 centimeter. The correct option here is C. 1 all over R equals to 1 over R1 plus 1 over R2. This will give us 1 all over 8 plus 1 all over 8. Therefore, our R is 4 ohms. So 4 over 8 will give us X all over 100 minus X. Therefore, our X will be 33.3. 37. 3 ohms resistor connected in parallel have a potential difference of 16 volts applied across them. What is the total current in the circuit? A. 12 amp. B. 8 amp. C. 10 amps. D. 14 amps. Again, our current I is equals to V over R. So this will give us 16 all over 4 over 3. And this will be equal to 12 amps, which is option A. 38. In the diagram above, a 200 watts bulb is lighted by a 240 volt AC main supply. If 1 kilowatt is sold at 40 naira, the cost of keeping the bulb lighted for a day is A. 192 naira, B. 1.92 naira, C. 19 naira 20 kobo, D. 1,920 naira. The correct option here is A. Let's look at how we got at A. The cost is equals to PT all over 1000 times cost per unit. So our P is 200, our T is 24, and when we divide that by 1000 and we multiply it by 40, which is the cost per unit, we arrive at the answer A. 39. Power supply is transmitted at a very high voltage and low current in order to 1. Increase the power supply, 2. Prevent overheating of the coil, C. Make it trivial fast, D. Make it pass through the transformer. The correct option is option B. Prevent overheating of the coil. That is why most of the lights supplied are transmitted at a very high voltage and a low current. This is to prevent overheating of the coil. 40. In the diagram above, if the south pole of two magnets stroke a steel bar, the polarities at T and V will respectively be A. North and south, B. South and south, C. North and north, D. South and north. The correct option here is C. North and north. 41. A galvanometer with full-scale deflection of 10 is to be converted to a voltmeter with full-scale deflection of 5 volts. If a series resistance of 498 ohms is used for the conversion, the resistance of the galvanometer is A. 2 ohms, B. 10 ohms, C. 5 ohms, D. 1 ohms. The correct option here is option A. 42. Two inductors of instances 5 mH and 15 mH are connected in series and a current of 5 amps flows through them. The total energy stored in the inductors is A. 250.0 joules, 50.0 joules, C. 62.5 joules, D. 500.0 joules. The correct option is option A. 250.0 joules. 43. In alternating current cycled at resonance, the angle of lead or lag is A. Pi over 2, B. 0 degree, C. Pi degree over 3, D. Pi degree. The correct option is option A. Pi degree over 2. In Faraday's law of electrolysis, a graph of mass deposited against a quantity of electricity is plotted. The slope of the graph gives A. The electrochemical equivalent, B. The charge released, C. The current flowing, D. The energy released. The correct option is option A. The slope of the graph gives the electrochemical equivalent. 45. In a discharge tube, most of the gas is pumped out so that electricity is conducted at A. Steady voltage, B. Low pressure, C. High pressure, D. Low voltage. The correct option is B. Low pressure.